All right, so get this. Today we're going deep on a theory that says it can explain the whole universe with just one principle.
Whoa.
I'm talking about the Grand Fibonacci SMF RVS theory.
Yeah.
And it suggests that everything, literally everything, from the tiniest atom to the biggest galaxy runs on the same fundamental law.
It's a big idea, that's for sure. Imagine like a universe where gravity is like reversed.
What?
Yeah, like a push instead of a pull, and
Oh.
where different star systems could have like completely different sets of elements. It's pretty
No,
mind-bending.
I'm hooked already. But how do we even start to unpack something this massive?
Well, it all starts with an equation.
Here we go.
G sub SMF sub equals V sub RVS sub X sub sub.
Is it boy?
Now, I know equations can be a little intimidating.
Yeah.
But this one is like a cosmic Rosetta Stone.
Okay.
It's like the key to the universe.
All right, let's decode it then.
Okay.
What is G sub SMF sub?
G sub SMF sub represents the subtle magnetic field. Think of it as a universal field, like an underlying energy that permeates everything
Okay.
and influences how particles interact. So it's not magnetism like we know it. It's more like a fundamental creative force. It's actually shaping the fabric of space-time.
So it's like the invisible hand that guides the cosmic dance.
Exactly. Yeah.
Wow.
And then we have V sub RVS sub, which is the relative vacuum of space.
Okay.
Now, we tend to think of space as empty,
Right.
but this theory says, no.
Uh-oh.
The vacuum isn't just nothingness.
Right.
It's actually a structured and dynamic entity that's full of potential energy.
Hold on. You're saying empty space actually has structure.
Yeah.
That's not how I learned it.
Yeah, see, that's what makes this theory so radical.
Okay.
It suggests that what we see as empty space is teeming with energy.
Right.
And this energy plays a huge role in shaping the universe.
Okay, so we've got this universal energy field
Right.
and a structured vacuum. What's the last piece?
That's where it gets really interesting. FLEMSUB stands for infinite fractal expansion.
Okay.
This is the idea that the same patterns keep repeating themselves
Good.
at every level,
Got it.
from the super small to the super big. Imagine the branches of a tree.
Okay.
Each branch looks like a mini version of the whole tree.
Right.
That's a fractal.
Okay, so you mean the same patterns that determine how electrons orbit an atom
Yeah,
also dictate the spacing of planets and solar systems.
exactly. It's like the universe is this giant, infinitely detailed fractal.
Yeah.
And this equation is the key to understanding it.
Okay, I'm starting to see how this theory aims to unify everything.
Mm.
But how does it explain the different forces we see, like gravity, electromagnetism? I mean, we learned about them as separate things.
Right, but that's the beauty of it. It suggests that all those forces are just different expressions of the same process,
Okay.
which is driven by the subtle magnetic field, the structured vacuum, and this fractal expansion.
So instead of separate forces pushing and pulling,
Yeah.
it's all variations of this one underlying, I don't know, cosmic dance.
Yeah, you got it. It's like a giant loom, weaving together all of reality with one thread.
Right.
And the patterns it makes,
Yeah.
fractals, repeating endlessly.
This fractal concept is really intriguing. Is there any evidence for these repeating patterns in the universe?
Well, one example is something from high school chemistry, maybe you remember,
Uh-oh.
the periodic table,
Right.
and those magic numbers
Yeah.
that tell you how many electrons can be in each shell of an atom.
Right.
Well, those numbers, they're not random.
Really?
They're reflections of those same fractal patterns that govern the large-scale structure of the universe.
Wait, so those little numbers in my chemistry textbook, they're like a secret code to the universe.
They are.
That's wild.
And it shows that everything's connected. What we see in atoms is mirrored in the cosmos.
Okay, I'm officially fascinated. But one thing that's still bugging me, gravity.
Yeah.
It's always been this mysterious force that pulls everything together.
Right.
How does this theory change that?
Get ready for this. According to the Grand Fibonacci SMF-RVS theory, gravity's not a pull. It's a push.
Wait. A push.
Yeah.
But we feel ourselves being pulled down to Earth.
I know.
So how does that even work?
Remember the structured vacuum?
Right.
Well, the interaction between the subtle magnetic field and this vacuum creates variations in pressure.
Okay.
And those pressure differences, that's what causes gravity.
So it's we're in this giant cosmic pool and the pressure of the water is pushing us down.
Kinda, yeah. And this push gravity idea has some pretty crazy implications.
Like what?
Well, For one, it could mean dark matter doesn't exist.
You mean that mysterious stuff that's supposed to make up most of the universe's mass?
Exactly. With push gravity, you don't need it.
Okay.
The vacuum itself can explain those weird gravitational effects we see.
So no more dark matter mystery. That simplifies things. What else? What other implications does this have?
Well, it also offers a solution to the black hole singularity problem.
Okay, for those of us who aren't, like, astrophysicists,
Right.
what is the black hole singularity problem?
Essentially, the way we understand black holes now, they're supposed to collapse into this point of infinite density, a singularity.
Uh-huh.
And that creates problems like paradoxes in physics.
Right.
But in the Grand Fibonacci SMF RVS theory, the structured vacuum reaches a point of equilibrium,
Right.
which prevents that infinite collapse. So no singularity, no paradox.
So gravity is a push, maybe no dark matter, and black holes don't collapse.
Yep.
This theory is turning everything we thought we knew upside down.
That's what a good unifying theory does.
Yeah.
Challenges our ideas, gives us a whole new way to see the cosmos.
Okay, but if every star system is born from this structured vacuum, doesn't that mean they all have to follow the same rules? Would the elements we have here on Earth be the same everywhere?
Ah, that's a great question. And it leads to one of the coolest parts of this theory.
Okay.
See, the Grand Fibonacci SMF RVS theory says that each star system actually has its own unique vacuum structure.
Wait, you mean different star systems could have different sets of elements?
Yeah.
Like something that's a basic element here could be totally unheard of somewhere else.
Exactly. Imagine each star system with its own periodic table, its own set of elements,
Okay.
and its own chemistry.
Whoa. That's mind-blowing. What would that mean for, like, the possibility of life on those planets?
Well, that's one of the big questions this theory brings up, and we'll get into that a little later.
Okay.
But for now, let's recap what we've learned about this mind-bending Grand Fibonacci SMF RVS theory.
Sounds good. I think I could use a little recap to, like, wrap my head around all of this.
Okay, so let's backtrack a bit and, retrace our steps through this cosmic maze. At the heart of it all is the Grand Fibonacci SMF RVS theory and that equation. G sub SMF sub equals V sub E via sub X F sub less sub. Each part of that equation represents a key pillar of the theory.
Okay, so G sub SMF sub, that's the subtle magnetic field, right?
Right. That universal energy field. Think of it as the conductor of the cosmic orchestra. It's influencing how particles interact and even shaping space-time. It's like this fundamental creative force that permeates and influences everything.
Okay, and then there's V sub RVS sub, the relative vacuum of space. That's where things get really weird, right? You're saying that what we think of as empty space actually has structure and energy.
Exactly. The vacuum is dynamic. It's not just like empty. It's teeming with potential energy.
Right.
And it plays a big role in shaping the universe. It really challenges our traditional understanding of empty space as just, well, nothingness.
And then we have sub-sub, infinite fractal expansion. That's the part about repeating patterns, right?
Right, exactly. Like, have you ever seen those Russian nesting dolls?
Yeah.
You open one and there's a smaller version inside, and then another and another.
Yeah, right.
It's like that. The same patterns repeating at every level, from like the tiniest subatomic particles to huge cosmic structures. Remember those magic numbers that determine electron shells in atoms?
Yeah, those numbers always kind of seemed random to me.
Well, according to this theory, they're not random at all.
So,
They actually reflect those same fractal patterns that we see on a cosmic scale.
wait, so those tiny little numbers in my chemistry textbook are like a secret code to the entire universe?
That's what they're saying. It really highlights the interconnectedness of everything. The same principles apply whether we're talking about atoms or galaxies. This push gravity idea is, well, it's really hard to wrap my head around. It's just so ingrained in us that things fall down because of gravity. Not because they're being pushed. It's a big shift, I know. But
Why?
think about it. If gravity was really a pull, wouldn't everything be pulled straight towards the center of massive objects?
I guess it makes sense. But then if it's a push, shouldn't planets be like flying out of their solar systems?
Yeah.
If they're constantly being pushed away from the sun?
That's where the structure of the vacuum comes into play. See, the interaction between the subtle magnetic field and the structured vacuum, it creates like a pressure gradient. It's not a uniform outward push. It's more like variations in pressure.
So it's these variations that create what we experience as gravity.
Exactly. And it's this pressure gradient that keeps planets in orbit.
Okay, I think that makes a little more sense. But We have to remember, this is still a theory, right?
Oh, absolutely. Yeah, it's a
Yeah.
model trying to explain things.
Hmm.
And it might need some tweaking as we learn more.
It's like the exciting part of science. You're always exploring and pushing the boundaries.
Right.
But this theory is pretty out there.
Mm-hmm.
Like, what kind of pushback does it get from the mainstream scientific community?
Well, some scientists think it's a little too speculative, not enough evidence yet. They say it needs more rigorous math and experiments to back it up. It challenges the status quo.
So kind of like the rebel of physics theories, huh?
You could say that, and sometimes you need those rebels to shake things up, right?
Yeah.
To challenge old ideas and open up new ways of thinking, look at quantum mechanics. Those ideas were considered pretty wild at first.
True, yeah. I guess it takes time for new ideas to be accepted, especially when they challenge, deeply held beliefs. But if this theory is right, shouldn't there be ways to test it, to actually find evidence?
Oh, absolutely. Scientists could look for variations in the gravitational constant in different star systems.
How would they do that?
Well, if gravity is really caused by these variations in the structured vacuum,
Right.
then the strength of gravity might be slightly different in different systems, depending on their vacuum structure.
So like sending probes to other star systems and measuring the gravity there.
Yeah, exactly.
And if it's different from what we experience here, that would be evidence.
Exactly. And there might be ways to detect these subtle changes in the vacuum itself, like maybe using advanced interferometry techniques. The technology for this kind of thing is always getting better.
It's pretty wild to think that, one day we might be able to actually test these ideas, and then, who knows? It could lead to breakthroughs in energy, space travel, all sorts of things.
Yeah, imagine if we could actually manipulate the vacuum to travel through space.
Warp drives, wormholes, that'd be amazing. But, this theory also gets into something that's always fascinated us, the possibility of life beyond Earth.
Right. And remember how we were talking about different star systems having different elements, different chemistry?
Yeah.
Well, that raises some really cool questions about what life might be like on those planets.
So instead of just looking for planets like Earth with water and oxygen,
Yeah.
we need to broaden our search.
Exactly. If this theory is right, life might not always need water or carbon. It could exist in environments that we would think are, hostile or even impossible. It's like opening up a whole new universe of possibilities. It makes you wonder, what would it be like to meet alien life that evolved under completely different conditions? Would we even recognize it as life?
Those are some big questions.
Yeah.
And it's why this theory is so captivating. It challenges us to rethink what we think we know about the universe and our place in it.
It reminds us that the universe is vast, it's mysterious, and it's probably full of surprises. And we're really just starting to understand it. This deep dive has definitely given me a lot to think about. It's like seeing the universe with new eyes, new possibilities.
Yeah.
But with all this talk about different star systems and alien life, what do other scientists think? Is this theory gaining any traction?
Well, like we said, some scientists are skeptical. They want more proof, more evidence. They want to see, like, the map worked out, and experiments to prove it. So it's still an underdog fighting for its place in the scientific world.
That's a good way to put it.
Yeah.
But even if it doesn't end up being the accepted model of the universe, it's started some really important conversations. It's pushing the boundaries of what we think is possible.
And that's always a good thing.
Exactly.
So what are some of the key takeaways here?
Yeah.
The things you think are most important for people to understand about this theory?
I think the most important thing is the idea of a unified vision. This theory says the universe isn't just a bunch of random, disconnected stuff.
Right.
It's all connected. It's a whole.
Okay.
And it's governed by these elegant principles that work at every level. From the smallest atom to the largest galaxy, everything is linked.
It's like all the pieces of this giant puzzle fitting together.
Exactly.
Yeah.
This theory helps us see those connections, to appreciate the beauty and the harmony in how the universe is structured. It reminds us that we're part of something much bigger than ourselves. Pretty awe-inspiring, wouldn't you say?
Absolutely. It makes you feel, small, but also connected to everything around you. It's humbling, but also exciting.
And remember, this is just one theory. There are lots of other ideas out there, each offering a different perspective on the cosmos. The search for a deeper understanding is never over, and who knows what amazing discoveries are waiting for us.
That's what makes science so cool, It's a constant exploration, always trying to unravel the mysteries of the universe. And even if this theory doesn't turn out to be like the ultimate answer,
Right.
it sparked all these new questions, new ways of thinking. And who knows, maybe one of our listeners will be the one to make the next big breakthrough.
Imagine that one of our listeners becomes the next Einstein.
Yeah, inspired by this deep dive.
That's right.
It's amazing to think about the potential for discovery that we all have within us. But for now, let's shift gears a little and talk about something else this theory touches on: the search for alien life.
Ah, yes. Are we alone? That big question. This theory definitely adds a whole new dimension to it, doesn't it?
It does. Like, if life can exist in so many different environments with different chemistry, different physics, what would those life forms even look like?
Well, that's where we need to use our imaginations.
Right.
Maybe they're silicon-based or nitrogen-based. Maybe they're made of elements we haven't even discovered yet.
Do you think they could be so different from us that we wouldn't even recognize them as life?
It's definitely possible. They might not breathe oxygen. They might not need water. Maybe they even exist in dimensions we can't even perceive.
Yeah. This theory really challenges us to think outside the box, doesn't it? Like, it's a cosmic invitation to expand our whole perception of what's possible.
I know, right? It makes you think, well, what if we've been looking for life in all the wrong places?
Hmm.
What if, like, we're so focused on finding planets just like ours, with water, with oxygen,
Yeah.
that we're missing, like, whole ecosystems that are totally different?
That's a good point. This theory really pushes us to expand our definition of life.
Right.
It's not just about carbon-based life forms, right?
It could be different elements, different environments, things we might think are extreme or even impossible.
Okay, but let's say there is life out there,
Yeah.
and they're, like, advanced,
Mm-hmm.
they have technology, they understand their universe.
Yeah.
Would their science be completely different from ours?
That's a big question.
Wow.
If each star system has its own vacuum structure, its own chemistry,
Right.
then yeah, their science, their understanding of reality could be totally unique. I mean, imagine they might have their own version of physics, their own periodic table, their own theories about how everything works.
They're like, we might not even be able to talk to them.
Maybe.
Yeah.
Or maybe it'd be even harder than that. Like, we might not even understand their technology, their culture.
It's almost like encountering a totally different, like, species, but on a cosmic scale.
Yeah, exactly. But think about it, it would be this incredible chance to learn, to
Right.
see the universe from a whole new perspective.
Yeah, like looking through a different lens. It could change everything.
Yeah, exactly.
I
And I
love that.
think it shows how important it is to keep an open mind,
Mm-hmm.
to be willing to question, like, everything we think we know.
This whole deep dive has been like one big challenge to everything I thought I knew.